Okay, so 13 and 14 we'll do together. Find the sample standard deviation for the following set of data. There's in the formula sheet, there's two different formulas to find the standard deviation for a sample. One is a regular formula and the other is a shortcut formula. I'll show both formulas, and I'll also show how to do this using the calculator. So first let's write the formulas up here. Here are the two formulas. S for sample standard deviation. We have the square root of the sum of x minus x bar squared divided by n minus 1. The other formula, S, the shortcut formula here, square root of n times the summation of the x value squared minus, oh no, I wrote that wrong, sorry. I did write that wrong. Sorry. The sum of the x squareds minus the sum of x squared over n times n minus 1. Okay. So first we'll show this formula. In my first column I'll put the x values. Just these values here. 23, 27, 12, 17, 16. Okay, so we've got to look at what all the parts of this formula are. So we have the sum of the x minus the means, the deviation from the means, how far each value is from the mean. So, of course, we need to find the mean first. So the mean of these five values, add them up, 23 plus 27 plus 12 plus 17 plus 16 divided by 5. Oh, why not use my calculator there? 23 plus 27 plus 12 plus 17 plus 16, and divide that by 5. So my mean is 19. That's my mean. X bar is 19. So how much do each of these values vary from my mean? Let's check. X minus X bar. So we need to find that. So 23 minus 19 is 4. 27 minus 19 is 8. 12 minus 19, negative 7. 17 minus 19, negative 2. 16 minus 19, negative 3. Now let's square that. I'm just following the formula. It says find x minus x bar, square those, add them all up. 4 squared is 16, 8 squared is 64, negative 7 squared is 49, 2 squared is 4, negative 3 squared is 9. Okay, those are all the components I need to do calculations for over here. Okay. Let's start putting them in. So I've got the square root of, let's add these up. Let's find the sum of the x minus x bars squared. So the sum of these, 16 plus 64 plus 49 plus 4 plus 9, it's 142. So I'll just, sum equals 142. So 142 is my numerator, divided by 5 values, 5 minus 1. So the standard deviation should be 142 divided by 4. Standard deviation is 142 divided by 4. Take the square root of that. 5.9, let's say 5.96, right? So let's say 35.5. 0.96. But I probably didn't round that properly. Let's round it properly. Let's do it this way. So since my values are all ones, right? All in the one, they all have a ones place. They don't have a tenths or a hundredths or a thousandths, right? So since they all end at the ones place, at the units digit, my standard deviation should end in the tenths. Should go over one position. So if I round to the nearest tenth, that's 5. So I round up, and this becomes 6. So my standard deviation should be, I should call that 6. There's my standard deviation. That's using the first formula. Let's use the shortcut formula and see if it's actually a shortcut. This formula here. So x value. So again, the x values would be 23, 27, 12, 17, 16. Just a little space there. So this formula says, take the sum of the x squareds. So I need to square each of these values. Do we need a calculator for this? 23 squared, 27 squared, 12 squared, got them all in there, right? 17 squared, and 16 squared, right? So let's write them all. 23 squared, 529, 729, 144, 289. And what's 16 squared? It should be 256, right? Yep. Now I have to add all these values up. I have to sum these. I probably should have did this better in the calculator, right? Would have been a little easier. So let's say 529 plus 729 plus 144 plus 289. 1947. Excuse my notation here. I don't really have enough space, so I'm using some weird notation. So the sum of the x squared, we need the sum of x, we need the sum of these values, which, did we do that already? Did we? No, I don't think we did. 23 plus 27 plus 12 plus 17 plus 16. 95. I did do that before, didn't I? Okay, so in this formula here, well, I can just do it down. I have enough room because I'm done with the table here. So standard deviation equals n, that's 5, times the sum of the x squares, 1947, minus the sum of the x's squared over n, 5, times n minus 1 times 4. So s equals the square root. Let's do 1947 times 5. 9735. Let's also do 95 squared in here. 9735 minus 9025. Over 20. So we've got the square root of 710 divided by 20. Let's hope that we get the same as the other side. 710 divided by 20. That's 35.5. That's the same thing we got over here. So we've got the square root of 35.5, right? Which equals, when I round, 6. So this is using the two formulas, the two different formulas that appear on your formula sheet. Again, we can also do this with the calculator. I'll show that right now as well. So if we want to find the sample standard deviation for a data set, just like before, we would go to statistics to enter some statistics, and I would go to edit. Oh, we've got all this stuff in here. Okay, let's get this out. Let's so to clear those lists, if I have a bunch of them, it's easier to clear them this way. Go to second plus for the memory. Second plus for memory. We're choosing option 4. Clear all lists. Hit enter, and it's done. And if I go back to stat to enter my statistics and edit my tables, everything's clear. So I put my values in: 23, 27, 12, 17, 16. Those are my 5 values. I go back to stat because I want to calculate some statistics now. One variable statistics, one variable. Just X, no Y's, no Z's. Enter. So my mean is 19, as we found before. The sum of the X's, 95. The sum of the X squareds, 1947. S of X, the sample standard deviation, 5.95, which we found, we rounded to 6. The population standard deviation, 5.3, if we wanted that. It's the other way you can find this information. And again, the 5-number summary is down here. Smallest value, first quartile, median, third quartile, maximum value. So you can get all that information from the calculator as well. Okay. So 14, find the population standard deviation. We'll do the same thing. We'll use the formula, and we'll also use the calculator. For this one, I'll just use the regular formula. That's the only one that they use in your book, so I'm just going to use the regular formula. Population standard deviation equals square root of the sum of the deviations from the mean. In this case, the mean is mu squared over capital N for the number of values. Right, not n minus 1, capital N. Okay, so same way, let's start with the X values. 32, 15, 27, 22, 26. And we want the deviations from the mean. So first let's find the mean. Let's add all these. Add them all up and divide by 5. I'll do it in the calculator again. 32 plus 15 plus 27 plus 22 plus 26. It's 122 divided by 5. 24.4 is my mean. So my mean, right here, 24.4. So we're subtracting each of these values here from 24.4. So first, 32 minus 24.4, that's 7.6. 15 minus 24.4, negative 9.4. 27 minus 24.4, 2.6. 22 minus 24.4, and 26 minus 24.4, 2.6 there, so 1.6 here. I will have to square these and find the sum. Square each of these and then find the sum. So let's bring back in the calculator here. 7.6 squared. Now, if I just wanted to do this, 7.6 squared plus negative 9.4 squared. Whoops. Plus 2.6 squared plus negative 2.4 squared plus 1.6 squared. That'll give me that sum that I need, 161.2. That'll give me that sum. Right? And I'll just do these regularly so we can have the values there. Negative 9.4 squared, 88.36. Oh, that's bad. 2.6 squared negative 2.4 squared 1.6 squared when you add all these values up, you get 161.2. So the population standard deviation, 161.2 divided by 5 values. Population standard deviation is the square root of 161.2 divided by 5, 32.24. Population standard deviation is, square root of 32.24, 5.7, approximately 5.7. So there's my population standard deviation. I don't know where that came from. So that's our population standard deviation. Let's pull in the calculator to also show that. So let's clear these lists. Second, memory. 4, clear all the lists. Let's clear all that. So stat, edit, 32, 15, 27, 22, 26. Put each of those values in. Go back to stat, calculate one variable stat, so enter. Mean 24.4. Got these sums. Sample standard deviation 6.34. Population standard deviation 5.678, which is what we got there. Okay.